think. Is it live yet? Let's check on YouTube. I think I got chat plugin to finally work. Definitely need to mute that tab. Okay, yeah, we're live. Cool. All right. You can post your questions to any of the channels. It's in the I'm behind on my pings. I'm behind on the messages. I'm still catching up today. I got back to a bunch, but I wanted to go ahead and try to give it a shot to focus a little more on the prep for this one. Let me post the link to the Discord group, though. Come on, come on, come on. Come on. There we go. All right, yeah, there's the Discord link. Okay, I'm gonna do a quick message to them to remind them that I'm live. And there's not really a Zoom link anymore since I'm using OBS. I might try dual streaming to Twitch. Now that I got that set up, there's a lot of things that I couldn't really do with Zoom that I can do a lot more easily with OBS. Okay, and again, I am catching up on, we're going to cover WebSockets for this one. I am hoping to cover WebSockets for this one. Yeah, I'm kind of, so I did cover this problem before, like about a year ago. And I covered two different approaches. One of them did use, yeah, I did. Yeah, I did use WebSockets, but it's not the best diagram of WebSockets. A better diagram is from the chat app problem, which I have over here. No, I can't just open it in a new tab. I have to do this, apparently. Yeah, this one had much better coverage of how to handle WebSockets. These are a little bit small. You can expand them in a new tab, though. You can open the image in a new tab, and I also even just have the Excalidraw file from that problem just kind of attached as well in the repository. But this one's a better reference for how to do the WebSockets, but I did also cover them about a year ago. But this is I covered online auction explicitly about a year ago. The chat app coverage is from about 6 months ago, which is also, I mean, it sounds like a while ago, but I think I was a lot more aware of what I was doing when I did the chat app coverage. So that one's going to be a better basis for the WebSocket component. But I did cover this problem once before. I'm just not happy with the coverage, so that's why I'm doing it again. Okay, I'm gonna like mute myself for a bit until we start so I can review some of the materials for that. I don't know if this is actually going to mute me properly. I'm still getting a hang of using OBS. We don't have, so since I've dropped Zoom, you wouldn't be able to do voice questions. So that is, you would have to kind of like type it out. I can try and like watch the general on Discord, the general thread on Discord if it's like a longer question. But unfortunately, yeah, you wouldn't be able to drop a voice question anymore. I haven't actually had anyone try to do that in like months. There's only been like a handful of people that have used that since I started like actually recording these around a year ago. It used to be relatively common when I was first doing these prior to recording them on YouTube, but yeah, people have just kind of stopped doing that as well. Yes, the schedule was changed for daylight savings. I'm also trying to make it a little bit more friendly for people on the East Coast, and also on in Europe. I have some viewers that are. I have a friend in the UK, and he's just never been able to watch any of these live. So yeah, we're trying this out. Okay, I seriously want to do a little bit of reading before we actually kick it off, so I'm going to mute myself. All right, sorry, I definitely did want to do some reading on this. It's going to be a really epic problem for that for the WebSocket when we get to that part. I'm trying to pull up the chat. I don't have it in a great place for trying to read it right now. Still getting a hang of OBS, like I said. Okay. I have it like shown on the thing, but that's like different than when I try and like actually read it myself. Okay. Yeah, general's fine for asking questions. I see your comment higher up. Excited about the session today. Yeah, hi Sarab. Thanks for joining. Yeah, I'm trying to be a little more friendly for the East Coast and Europe. I do live so the schedule has changed. Okay, I think I already addressed all those, but yeah, I just try to make sure that I do actually answer people. Okay, so today we're going to be covering the online auction problem. Shoot, is it? Oh, that's right. Okay. Trying to get a hang of the chat again. I forgot this thing's gonna go away when I click off something else. Screw it. Okay. All right, starting again. All right, online auction. We're going to be covering that problem today. It might look a little bit similar to the ad click aggregator or metrics and alarm service from Alex Shu Volume 2. Those ones, I mean, so those ones are like heavy write volume. I don't know if those are actually going to have as much overlap as I had originally thought. The flash sale and Ticketmaster problem might help a bit, although in this case, I don't believe we're actually going to need to have the real-time constraints thing that you kind of need to have typically for flash sale and Ticketmaster. Of course, we're going to have the three, usual requirements that you would expect from this, that users can list an item for an auction, users can submit bids for any given item, and users win the auction if they have the winning bid. There's two variations of this. There's the fixed auction deadline, and then you have the moving auction deadline. So the first one, the fixed auction deadline, I believe that's how eBay usually does that, where you're able to submit bids up to a fixed deadline, and then once that deadline from that you get upon opening up the auction, the deadline never moves. And if you submit a bid after that, even if there was a dozen bids in the last 5 seconds, the deadline doesn't move. The other variation is where it's moving. And so the auction's deadline keeps getting bumped to like 5 minutes after the most recent bid. I think this is a little bit more reflective of real-world auctions, where you see like the really fast talking dude, where there's like a little pause after every bid, and they'll give you up to like 3 seconds to go ahead and submit a new bid. I didn't really fill this out yet. We might fill it out as we're going through it today. Yeah, okay, so we're going to go ahead and start drawing some diagrams. If you guys have any questions as we're going along, feel free to drop them in the chat, and I'll be watching it. Yeah, okay, so we're going to start off with that requirement of the listing an item for an auction, so the auction opening part. So we're going to draw that a user can, what I say, it's the auction listing service. So user creates auction. Actually, let's call it user lists item for an auction. And then we're going to have user views auctions. Okay, so those are going to need two different backend services. We're going to have the auction submit service. I mean, this could be on the same service. You don't actually need to have the two endpoints on completely different services. Usually they are drawn differently since they would have a very different scale for them. And so then they'd be independently deployable, independently scalable. This would be the auction listing service. And then we're also going to have the auction viewing service, which is where you're able to see the list of auctions that are available. And we're going to have a data store for that, of course, and it will be the auction data store. And it'll also hold a little bit of metadata about our auction as we're going through it, as it's taking bids. Let me zoom out a little bit. This one's pretty straightforward. It's just kind of like a very basic like CRUD database. It's really obvious access pattern. This one comes in, you do your key range query, and then you get your response back of the list of available auctions. And then, of course, the more interesting part is going to be handling the actual bids, submitting bids, and the closing part is going to be rather tricky as well. So we're going to have user submits bid. Yeah, user submits bid. And we're going to have user, what is it? User views bids. And we're going to start off with just the very basic approach of just refreshing the page in order to see the latest bids. But we are going to get around to the WebSocket approach, of course. I like to cover a couple of approaches. Okay, and we're going to have the bid submit. We're going to have the bid view service. Okay, I did already do my homework a little bit on this. That's why I was really quiet at the start, is that I just know for a fact that the WebSocket part is going to get really tricky. And I did already do some homework on here. That's why I was so quiet at the start. And I'm kind of referring over to it, but it's not fully filled out. So for user submits bid, you're going to have the go to over here. You're going to have the bid data store. We're going to talk about the schema after I put this on there, and then we're going to try and fill out the closing part. So we're going to have, this is the bid data store. Okay, and then you're going to write it over to the bid data store. Okay, and then you want to do a read. So you have, you say, hey, bid view service, what are the bids for my current auction that I have open? Do your key range query, and then you get your response back. So that's the basics. That's the basics of it. There is a way where you could partition this as one data store where you don't need two different DBs for this one. I'll go ahead and go over the schemas, and so then we can kind of show you how that works. But for starters, for the auction service, we're going to have an auction ID. Come on. You'll need the auction ID. You'll need the user ID for the person that's selling the item. We'll say that I'm selling some kind of item. I think we're going to kind of want to have a status. That's definitely going to become really important later. We're going to have a deadline. Deadline 67000 5000. Say open, closed. I think we could even have a closing status as it's trying to close it. We'll see how that's useful later. Let's go ahead and fill out the bid data store. This one's going to be a little bit more interesting, I believe. So you're of course going to have the auction ID 2345. This one's going to be the partitioning key, which is going to be pretty important for having for handling the write conflicts. If you get two bids at the same time, is that it's kind of important to have a total ordering. That's actually something that I think I kind of wanted to discuss here, is the consistency level necessary. That's going to be important. And so that's kind of like a key piece of like why I have to recover this problem, is that my original approach we went with Cassandra, which is leaderless, and it's not great for transaction support. And as a leaderless database, it's also you can get causal consistency on it. I guess that's you. Some leaderless databases, such as Cosmos DB, can get causal consistency. It was, and you can actually get linearizability with leaderless databases. That's actually covered in Alex Petrov's book, Database Internals. He covers Calvin, which is for FAANG uses a sequencer in order to get linearizability on a leaderless database, which is how you would do that if you wanted to go that way. I had originally recommended Cassandra, though, which is, I don't think Cassandra uses a sequencer, so I don't think it can actually support something stronger than, I don't think Cassandra even supports causal consistency. So that's going to be an important topic to cover when we're kind of picking at our DB and our schema here. I'll go ahead and kind of give a high-level summary, though, right now before we keep digging into this. I think it's going to be pretty important. Linearizability, and then you have sequential consistency is a little bit weaker, and then you have causal consistency, and then you just have read your own right. Which is called strong. I believe this is what they're talking about with strong read consistency in DynamoDB. It's so that doesn't handle that doesn't handle write conflicts. It does last write wins conflict resolution. And so then it just overwrites the other one, and it doesn't really, it's not super great. So this one does have, you can specify your own conflict resolution. And then for this one, you have total ordering. This one has real-time database constraints. So although you have the total ordering across everything in the database, you're not able to enforce like a uniqueness constraint or something like that. There's other things. You can't prevent a record from being written if it violates a constraint in your database. You can't really say when a user is trying to do a write operation on the database, you can't give them a 50x back if there's already something else with a given price, for example. So if you wanted to prevent somebody from submitting a second bid for the exact same price as what was given a millisecond ago, you wouldn't be able to do that with sequential consistency. You can do that with linearizability in this case, because it provides real-time DB constraints. I don't think we actually need those in this case. We might actually only need causal consistency, and I said above that with things like flash sale and Ticketmaster, you do actually kind of need to provide real-time DB constraints, but I don't believe that we're going to need it in our case. I don't know if you do need total ordering across all the bids that are coming in for a given auction, but I believe that actually might only be considered causal consistency because it's not across different auctions. It's only within a given specific auction that those causal requirements are important. So anyways, continuing with this, so the auction ID is going to be our partitioning key. And we're going to have a bid ID, I guess. I'm not 100% sure if that's fully necessary, because we're also going to have the user ID and a timestamp. And I don't know if a user would really be submitting two bids in the same millisecond. That would be a little absurd. So I don't think it would actually be completely necessary. Let's say that the user ID is, I don't know, Hunter12. Then we're going to have the timestamp of their bid, which is going to come from the backend service, of course. Okay, so we have the timestamp. So that one's probably going to be, so your sort key is either going to be the timestamp or it's going to be the bid ID. I'm going to go ahead and put this in parentheses because I think that this is not completely necessary. You might be fine with just the timestamp. I mean, if you have a interviewer that like really challenges it and really has some doubts, maybe you should go ahead and try the bit ID and use some kind of sequencer for like creating the IDs or something. I don't think it's completely necessary though. Okay, so this one would be the sort key though. All right, and you're also going to want to know the amount that they bid. So amount, let's say that they had bid $50. And, I'm using a string here. That is kind of intentional. I believe I've seen a lot of money handled with strings. You don't actually want to use a float for money. It's a little dangerous. An int is acceptable, but a float is not. I've seen a lot of this actually handled with like a string, and then you just trust a different system that is in the accounting department for handling money properly. And it just provides you the numbers back as strings or something like that. Okay, so this is one approach to it. Another approach is where you go ahead and do something kind of like what we had with it was either the hotel booking problem or flash sale, or even with, what was it, Ticketmaster. You can also just combine these. I can kind of show that. You can have that as a different approach. I'd rather avoid these kinds of ones where you have the combined database, because it means manual provisioning, manual partitioning, and that's just going to be an absolute pain in the ass. And I'll show you how the schema is going to work for this. So it's just, you do have the two different tables, and you are going to partition it over the auction ID, and you're just going to do manual partitioning. And that's actually the only partitioning key that you need for the top table, and I can even go ahead and specify that up here. I don't think you would actually really need to have a partitioning key even. It would probably just, you would only need one machine for the auction data store, and then you might need some read replicas, but you'd probably be able to get off with just having one machine as the main replica accepting rights. And this is fine for a primary key because it is unique. It does provide uniqueness. So you'd partition over the auction ID, and then just the chunk of this second table that is under the given auction IDs for that chunk from the first table is just what's going to be in that chunk of the table. I don't know if I explained that entirely great, but I did show this in a bunch of other different problems, like hotel booking. Again, it's in the updated diagram for it is for hotel booking, and also in Ticketmaster and flash sale. And then I should just go ahead and name the tables though. You also have the bid table. So then we have this, and I haven't drawn how to do the closing service. That's what we're going to do next. So let's go ahead and draw the closing service. So we can call this approach 1. We can go ahead and call this other one approach 2. And now I want to draw the closing service. Okay, so you have bids coming in over to here. We have the schema like this. We're going to go ahead and so I'm imagining that let's say that you don't necessarily need to have the auctions closed immediately upon the timestamp being immediately upon the deadline for the auction. We can have it as a daily job. So if it's okay to put off the payments until end of day, you can just have this gigantic batch job that's closing out the auctions. I mean, you see this all the time with a bunch of different banking services that it can take like several days for stuff to close. So if we're okay with that, we can go ahead and have a bid OLAP data warehouse. And we're just going to go ahead and do a DB trigger for change data capture. Let's have that one centered like that. Okay, and so it's going to go ahead and get a continuous stream of the bids. In reality, there would of course be like this little stream or something, and there'd be some kind of stream or something involved in the process of the change data capture. Let's bring that to the front. Okay, and then at the end of the day, you would have this gigantic batch job. This is the what is it? Closing service. We're going to go ahead and call it the closing service. It should be it's a bunch of workers, a bunch of worker machines that are going to be doing this. Probably like a Spark job. You can also alternatively turn it into a push against a real closing service, and I can go ahead and draw that out as well. To start with though, we're just going to go ahead and have the closing service kind of like that, and we're going to go ahead and stretch this out more towards the top. So we have these closing service workers. They are like Spark jobs. So you're going to have this. You will need to be handling some payments against an external payment providers like Square or Stripe. Actually, Stripe is the most common one, and so you're going to want to do the auth capture workflow. But yeah, we're going to have an external payment processor like Stripe. Let's zoom in on this. You're going to be dealing with the auth capture workflow. So you pull in some data, and then so we know who the winning user is. You might want to go ahead and let's go ahead and update a status for who the winner is. This thing's going to be mutable, and we're going to use the status field for tracking this. It's going to track that you're now closing that one out. There could be a couple of statuses involved in this. You would write the winning user ID over to this thing, and then you're going to go ahead and do the auth step. And then you should actually probably persist that over here. Otherwise, you can get multiple charges over the same thing. You have to persist the auth step, and now you can go ahead and drive the the capture step against the service. And then when that's successful, this is even so. The auth capture workflow is to make all the steps idempotent, and so then after the last one is done, you're able to retry this until it succeeds, and you're also going to need to record that against the auction data store. So there's a series of calls here. This would actually probably be best as a orchestration component. Would probably be pretty great here. I did kind of want to see how this would work if you're just having it like push over to a if you're having it push over to a service, as opposed to having this thing that's like a Spark job. I feel like a Spark job is a little bit unrealistic for when you're going to be making API calls. Spark jobs are not really meant for API calls. So you would need to figure out who the winning bid is of a given auction, though, and there's probably going to be a bunch of auctions throughout the day. So maybe that part would require a Spark job. But you can go ahead and explore that idea a little bit. So I think the orchestration is actually going to be a little crucial. You do kind of need to keep the orchestration there. The Spark job, though, I feel like that is probably that's pretty realistic. And then you can go ahead and probably send the results over to Kafka. And then this is going to look a little bit like a Rube Goldberg machine. It's going to be a little bit ridiculous. But this is what I'm familiar with for how you would, you usually decouple OLAP services from OLTP services with a broker like Kafka. And so after you go ahead and identify the winners of each auction, you could go ahead and put some messages on here for the auctions and the winning information on each of them. And then you would have some task runners, just a lambda trigger. You can pull those off. And then you can go ahead and kick it to a service. I think that the way that AWS step functions work is actually going to look the most like how a service would behave. But you're probably going to want to keep an orchestration component. This does look wild, and there's probably a way where you can just go ahead and keep it a little bit more like this, but if you wanted something a little bit more, I don't think you can actually have AWS step functions doing some kind of OLAP operation against a data warehouse. So this would be like Redshift or Iceberg, Apache Iceberg set up on top of Parquet files or Hive or HDFS. So you're able to do those big processing jobs on it. We're also going to look into a way to have this being done continuously so that you don't even have to travel over to OLAP world. We're going to do that next. I am going to get to WebSockets more towards the end. I feel like my original coverage was really crap on this little aspect right here. Is the closing service is one piece that sucked. I didn't even talk about what data store I'm actually going to go with. So over here it's manually sharded PostgreSQL. I see your questions in the chat. I'll get to that in a minute. I'll get to that after I pick out all these data stores, and then I'll write down my game plan. Pick data stores, answer questions, and then we're gonna do probably gonna do continuous closing approach, and then we're gonna get to probably WebSockets. Now I also need to do something about. So we have two variations. We have the moving variation, and then we have the fixed deadline variation. And we can talk about that more towards the end. This is currently just kind of doing the fixed deadline variation. And then we'll cover the moving deadline variation towards the end. So that's my game plan for right now, though. Okay, so we have manually sharded PostgreSQL over here for approach 1. So over here, you're either going to be able to do PostgreSQL or you're going to be able to do DynamoDB with just plain strong read consistency. It's going to be fine for handling the status part. You don't need anything better than strong read consistency there. You're not really doing anything with transactions. It's anything stronger than that, I feel, is a little bit more of a it might be more of an isolation property, than a consistency property. Consistency is over singular records, while isolation is over multiple records. And so isolation is write skew, read skew, but we only care about singular records here. And when we're operating on this one, all those bids are only talking about a single record in this data store. So DynamoDB is fine over there. Over here, so I had previously brought up Cassandra, and the reason why that's naive is that it has last write wins. So you could have two bids literally could come in at the same time and hit it, and it would not necessarily be able to provide a proper total ordering over that. So Cassandra is kind of naive. There are leaderless systems that do provide total ordering with a sequencer, like I said. FAANG, like I said, might actually work here. That could work, and it is leaderless because it uses a sequencer. Or you could use DynamoDB, which is single leader, so that does work here actually. I don't know if you even need causal consistency though. If you did, that's where Cosmos DB could also work great here. Another option is Spanner, or you could use manually sharded PostgreSQL. And I think that DynamoDB is going to be perfectly fine because it is, like I said, it is single leader based, and so it can handle doing total ordering. Actually, it's okay. You know what? I am kind of having some second thoughts about that because it doesn't actually allow you to do an auto increment. It doesn't allow you to do an auto increment, and I don't know if you can actually get a timestamp. So I'd imagine that the timestamp would be with a monotonic clock. I don't know if you can add a timestamp as a field in DynamoDB or if you would rely on the servers for that. I'd prefer if it's like given by the database that does the sequencing for us. And so if you're doing manually sharded PostgreSQL, it can definitely handle that. So I am actually starting to lean towards manually sharded PostgreSQL now, because I don't think that DynamoDB actually could provide, I don't know if there's actually an operation where it'll do some kind of sequencing for you, even though you are providing a partitioning key where everything within a partition would be, you would be able to properly make it sequential very easily without a sequencer component. But I don't think there's anything in DynamoDB that would allow you to take advantage of such simplicities in its architecture. So I am sort of leaning towards manually sharded PostgreSQL here. And so Cosmos DB does have write conflicts, a write conflict resolution thing. You can use CRDTs, but you have to roll them yourself first of all, and then also it's like those. I'm more familiar with how they'd work on individual records, while we're just kind of doing event sourcing. We're just kind of doing event sourcing here with an auto increment field. And if you're doing manually sharded PostgreSQL, that's very straightforward, super straightforward. I don't like Spanner because it requires an atomic clock, and it's like, so that's expensive. And instead of laying off some engineers over the last few months, how about you just don't use a hardware component that literally requires making its own atomic clock. It's unnecessarily expensive, I feel. I have heard that Spanner is definitely more expensive than DynamoDB. I've only heard of one or two real world use cases where people are kind of like able to justify using Spanner. It was Uber has one, but it's not usually easy to justify. Okay, was there anything else that I kind of wanted to give data store choice for? I guess I could talk about this. I did already bring up Spark over there, and this one's AWS Steps. And then again, I didn't actually go through, I didn't write down my choices, but I did talk about them. So it's like Iceberg. Let's do left align. You can do Iceberg, which is on HDFS, uses Parquet files. Could use, Redshift, I believe, is a data warehouse thing that you can use. I know there's also like ClickHouse, and I think Databricks also is an OLAP database. So just stuff like that. It's a data warehouse. You're going to run some Spark jobs off of it, possibly. I'm pretty sure. Well, so if it's in an OLAP data store, yes, that's like the whole point of sticking over there. Is like, hey, we're going to do some really expensive read operations, some really crazy queries against it that are very computationally expensive, and you wouldn't really be running orchestration directly on top of it. This one's a little bit unrealistic. It would look a little bit more towards that. We're going to cover the continuous approach too, where it looks a little bit less like a Rube Goldberg machine, but we'll get to that after some questions. I'll go ahead and read through the chat now. Let me pull it up. What would be choice for this combined data store? Oh, yeah, I'm happy I got to that. So you were thinking ahead a little bit, and I was feeling manually sharded PostgreSQL. How can the calculation for determining the necessary number of workers? Here, I'm going to go ahead and paste these even though I have a live chat thing. It's not greatly formatted yet. I'm still getting a hang of how to format stuff on OBS. How can the calculation for determining the necessary number of workers be done? How many workers? That's a great question, actually. That one is a lot. So it's computationally bound. It is computationally bound. So estimating the number of like workers for a Spark job is really tricky. I think it's just like as much as you feel like. It's like go ahead and throw 20 machines at it. I am using Spark at work right now, and it's like just however many I feel like I want to use. I don't like estimate it. It's like, it's a large processing job. Just go ahead and give me however many machines that you have. It's like 20 to 40 is generally what I've seen though. If you have like 100, I feel like that's probably excessive. And you might want to do something more efficient, or I don't know. I've never seen a Spark job that has like 100 machines running for it though. I've noticed that Lambda functions are employed in the ads aggregation system too. So Lambda functions are usually serverless. It's so usually for Lambda functions, if you're doing what was it called? A Lambda trigger where it's just listening to a stream. Usually what you do for Lambda triggers when it's just a task runner listening to a stream is that you just have one machine per shard of that stream. So however many shards you need for Kafka to handle the amount of volume that you're throwing at it is probably going to be the same number of Lambda functions that you're going to need listening to that stream. So for example, if you're throwing like 100K TPS, if we have 100K TPS of bids coming through the Kafka stream right here, that would be, I believe Kafka, what was it? It's 10K TPS per shard, I think is what it can handle. Is it 10K? It was at 100, it was 10 TPS of reads of like 1,000 messages each, I believe is what the specs were. And that's just the read volume, which means that you can go ahead and dump data at that rate without getting back pressure. So you would need 10 different shards just for that. And then that would mean, 10 shards. So then you would want to have 10 Lambda trigger machines listening to the shards of it. So that's how I'd figure that part out. Going through the other questions, can you elaborate more on CDC with DB trigger and why do we need a big OLAP data warehouse? Sure. So actually let's go ahead and split it onto a couple of lines just like this. So CDC means change data capture. And DB trigger is just built into your database. So this is just like a thing for passing data downstream. It's like a common, so when you're doing sagas, if you're doing the saga distributed transaction approach, you're usually going to do CDC with a DB trigger. Sagas are usually very reliant upon DB triggers. It's a great way to allow data to go through several steps without having some really nasty partial failure scenarios, because you're able to retry that next step very easily. And so we just want to pass it downstream. You don't want to run, so it's like, why do we even need this in the first place? Is like, so I need the OLAP data warehouse there. That's why we have the CDC there. But it's like, okay, so why do you need the data warehouse? And that's because you don't want to run OLAP operations on the bid data store. This thing is actually so that is going to be considered a OLTP database. And you don't want to mix OLTP with OLAP because whenever you run a big OLAP operation against your OLTP database, it's going to slow down a lot. It's going to get these massive latency spikes. It's going to really put some strain on your OLTP operations. So you're going to get some like dropped write operations, for example, is what's going to happen. OLAP is really bad for OLTP. You also don't want to run OLTP against OLAP because they're optimized for different things. When you're doing an OLAP operation, you're basically doing these full table scans. That's what these are usually doing, is like a big gigantic full table scan. This is going to be I envisioned just one big batch job that's going to look through all the auctions from today that got closed out, and it's going to go ahead and do all the payment processing for it. It's going to go ahead and settle all those auctions. It's going to figure out who won. You can actually figure that out live. I was going to look into that a little bit more for the continuous scenario, but I did want to go ahead and explore an end-of-day closing operation as one approach. And so this is how it would look, is that, hey, it's going to be massive. That's going to be one singular gigantic full table scan. And so the way that data warehouses are optimized for a full table scan is that they're columnar, as in they store the data locality for the columns they have data locality for the columns on it. And so you have these like Parquet files usually for Iceberg is a common setup. I think Hive also has its own data format that you can alternatively use in your HDFS setup. But this thing's for these big full table scans, while this one is handling 10,000 TPS per node per machine. And so in this one we'll have a bunch of secondary indexes possibly. It has B trees, it has maybe LSM trees alternatively. It's optimized for looking up singular records really quickly. It's just the way that the database is oriented around read efficiency is completely different between these two things. And if you try to run the OLAP workloads on the OLTP, they don't mix well. And so that's why you do that. So I'll just summarize that as OLTP doesn't. I heard this from my source for this is Steve Hun from the YouTube channel A Life Engineered. He's a principal engineer from Amazon, and he has firsthand experience with these mixing really poorly. So I'm not making that up. He said something like, well, so if you do this, what you're going to have is these business critical reports getting run against your OLTP database, and then you're going to get these really massive latency spikes from that report running, but you can't kill the job. You can't kill that OLAP job because they're business critical jobs. And so whenever they run, you're just going to get this like horrible performance for these writes. You're going to probably get some dropped write operations, maybe some dropped reads. You're going to get degraded availability, and there's nothing you can do about it because these are business critical OLAP jobs that are running. All right, moving on with the live chat. Please explain what data you're aggregating to the bid OLAP DB that helps in closing auctions. It's just like for determining who the winner is. That should be done live. You can figure it out live with the key range query that you would be doing on the view side. And so you would be able to see that, but it hasn't actually tried to close it out with an external payment processor. And so if there's hundreds of bids that have gone into a given auction, there's hundreds of bids that have gone into the auction. The key range query can actually be done really, really efficiently, because you can do a sort by with the timestamp, and you would have the max bid sort by the timestamp less than the auction timestamp. You would load that information in on the client side, or you could have it cached somewhere. I don't know. Maybe I should have thought that out a little bit more. Oh, I mean, I guess you could do a quick read off of this for a key value lookup, or you could even have a co-located sidecar deployed Redis cache that's pulling that stuff in. But I guess you would go ahead and you would kind of need to do a quick key value lookup off of a cache first before you can do that, since you're going to need to have that deadline clause for the where clause of the SQL query and that key range query. But so this can be done really quickly over here. It's just that it hasn't actually gone into the auction data store. It hasn't actually like reflected the winner over here or done any of the payment processing. So you do still need to do that. And I'm gonna go ahead and paste that over. My overlay on OBS is not the greatest, so I think you did get cut off before I had properly answered this. Yeah, external payment processing. There we go. And I'm going to get through the continuous scenario later on after getting through these questions here. Is Spark used for processing streaming data from live auctions, or to streaming data from live auctions to provide real-time analytics, or to trigger alerts based on? It's not for streaming data. So there is Spark Streams. I am familiar with this, but we're actually using, we're just doing batch operations, not real-time streams. In fact, I don't think you actually want to do real-time analytics in this use case, because it usually uses the count min sketch algorithm, which is which does estimates. You don't want to do an estimate in this case of who the winner is. Real-time analytics is not actually the way to go here, I believe. If not, what are some other use cases for Spark here? We're actually doing Spark Batch, not Spark Streams. Great question, though. I am familiar with how there's Spark Streams there, and I did have a stream over here, so I can see where that confusion would be. But yeah, we're just doing the gigantic batch job once a day. Does auction need payment to, and do you need two-phase commits? We are handling payments. That's what this thing is over here. Yeah, it's a great question. Because you do kind of have like this two generals problem. You want exactly one's processing with an external payment system. You want to make sure that you only get paid, you only charge them once. And that actually is not what's happening here. Instead, you have this thing called the auth capture workflow, and you can actually see great resources for reading up on this is Stripe's documentation on that thing. I also did a video on it, and payment gateway. My payment gateway coverage kind of covers it. Is that the reason for this is that it makes the process idempotent. And what you first do is the auth step, which is where you generate this, you freeze a certain amount of funds on the buyer's card. You're saying, hey, allocate this chunk of money. And then you do the second step. So this one actually gives back a UUID. And so that's why we're persisting it over here, is that we're persisting that UUID for the specific auction. It's the UUID of what we're going to charge. And now after that's persisted, we can go ahead and run the charge of that idempotent UUID in an idempotent manner. You can go ahead and run that UUID from the auth step as many times as you want, but it will only charge it once against the external payment processor. So if you don't get your response back, if you get a dropped packet on the way back, you can safely go ahead and rerun the call and until you get your 200 success back, but it will only actually charge on this guy's side exactly once. It will not charge them multiple times. The whole thing is just for item potency, and you don't have to figure out a two-step a two-phase commit between you and this external party. That would be a huge pain. It's because there's the really nasty miss of the termination guarantee for two-phase commit. There are cases in prod where two-phase commit is used, like Dropbox does actually use two-phase commit. So I mean, it's not like the most wild thing ever to see, but yeah, it's we were actually able to avoid that with the auth capture workflow. What locking do you use? I don't know if we actually even use. I don't know if it's even considered blocking. It could be considered optimistic. So I don't think I would call it pessimistic locking. I don't know if I would call it pessimistic locking. So, wait. That didn't copy your message properly. Sorry. So I don't know if it's even using a locking process. If anything, it would be optimistic, but I don't know if it's considered locking. So is the use of OLAP warehouse here is to So is the use of OLAP warehouse here is to aggregate data to calculate metrics such as total revenue, the average price of items sold, or the total number of bids. It's just to find the winning bid. It's just to find the winning bid. Because so you have to find the max price, the first timestamp of that max price, and it also has to be before the deadline. And if you're doing a moving deadline, that is actually going to require some kind of window aggregate function. So there's a couple of key things here. Is max bid is one part of your where clause. Max bid, first timestamp of that max bid, and then also prior to the deadline occurrence. And I mean, if it's just a fixed deadline, that's not going to sound, this one doesn't seem like a big deal. But if there's hundreds of bids that go into a specific auction, I mean, it could be scanning over several hundred. Maybe you would be able to do a simple key value query for each of the auctions that would just, I think I mentioned that you are able to do that over here on the bid view service to see it continuously. So maybe it's not fully necessary to have the OLAP operation. Maybe it's not really as expensive as I was thinking. But if you're going to be running thousands of those at the end of the day, I mean, that still would be a massive spike in traffic that happens right at the end of the day. And so then that would kind of be some strain on the database, and why you would want to switch to the continuous approach rather than this. And so the continuous approach is probably going to be a lot more superior. And we can get to that after I finish closing out these questions. Or, I can go ahead and do that, and then I'll answer more questions. I'll do that, and then I'll answer the other questions. But yeah, it's literally just to find the winning bid. All right, let's go ahead and pull this. So we can call this continuous approach. Okay, so instead of that, you can still do, so with every bid, you're going to be updating, you could potentially be updating what the winning bid is. You wouldn't necessarily need to go all the way through the closing process, but I guess you are going to have some kind of thing that is, you're going to have some kind of DB trigger going on. You will need some kind of DB trigger. So you're going to need to have some kind of DB trigger that is, it's going to be watching for whether or not the auction has just closed out. So with every bid submitted, this thing is watching whether it has finally closed out. Well, so what if your bid, what if the bid is not, so if you submit a bid before the deadline, you don't know if that's going to be the bid that closes it out, though. You don't know if that's the bid that closes out the auction. You can watch for what the winning bid is. You'd be able to figure that out after the auction is closed off, but you would need to have some kind of scheduled thing for figuring out that the auction is finally closed out. So actually, I think you would need to go ahead and do polling against the database instead of a DB trigger. Your DB trigger can only watch for the current winning bid. So I don't know if that's actually going to be enough there. Yeah, I think you would actually kind of need to do some kind of polling against it. Lambda is kind of able to do that. You can kind of do that with some Lambda triggers or Lambda functions. Or you could even just have some dedicated workers that are continuously polling it for auctions that have closed off within the last range. Okay, so you're polling it for what has closed out, and if you find things that do need to be closed off, you can go ahead and send them over to the orchestration thing over here. You might communicate, so you still might communicate over Kafka for this, although I guess you could probably keep it idempotent. Might be a way to keep it idempotent. I mean, the whole thing should be idempotent. When you're looking at this, it should even be checking if you've already closed out the whole payment process. But you might possibly still have Kafka for decoupling these two things. So I'm just going to go ahead and draw this. I'm not 100% sure that Kafka is completely necessary there. But if you're going for an SOA architecture, like at Amazon, you'd probably have Kafka here if it was something that was designed by Amazon. But if it was just like a startup, you'd probably not have anything between these two components. Okay, so you have the auctions that you closed out, and then this thing's just going to be working on that auction. Okay, let's go through some other comments on live chat. Oh my god, I hate this thing so much. There we go. How do you update the max bid placed in real time and show in auction viewing service? How do you update the max bid placed in real time and show in the auction viewing service? So you're able to do that with just a key range query is what I was saying. And I can show you how that would be how that would look is you do select star from bid table where I'm gonna need the schema here. Going to have timestamp is less than or equal to the deadline. That's where I mentioned that you might need a co-deployed Redis cache or something, or you can just go ahead and do a quick read off of the auction data store. And you have the highest amount, so you can do order by, you would do the amount, and then you would order by timestamp. I'm not familiar with how to order by two things in like one and then the other in case there's like two matching bids. But you would order first by amount and then by timestamp, and then you would take the one at the top. So then it would be like limit 1. Okay, and then so this one's also going to be a secondary key. Or secondary index. Going to need a local secondary index on that. I don't think you need anything else for that. Of course, if it's a continuous thing, this would be, you would not be able to do this in the continuous case. I think the continuous case would really need OLAP for closing this out. Or you would maybe need to update when the closing time is continuously. So in that case, for the continuous one, you would maybe have the DB trigger, and you would check whether or not it's a valid bid. And if it is a valid bid and it moves the max, you would go ahead and update the deadline over here in the auction data store. Let me go ahead and draw that out really quick, actually. So this one is the fixed deadline variation. I said I wasn't going to get to this until the very end, but it is actually kind of worth drawing out right now. Now we're going to do the moving deadline variation. It wouldn't be polling. I think you would just need to have DB triggers directly for that. Well, actually, you might actually still need to be doing the polling thing because you still can't tell whether or not the max bid has finally closed it out. But you are going to need to have a DB trigger, but you're still going to be doing the continuous polling as well. I think it would also actually need to pull the auction data store as well for that information to watch the deadlines for the open auctions. So it would look at what the current open auctions are. It would get the open auctions and what their deadline is to determine whether or not they've passed. And then it would be able to try and close them out with the orchestration service and the next step over there if it does finally find something that needs closed out. But you're also going to need the task runners for updating the moving deadline. should specify eligible, because what if the max bid comes in after the deadline? Okay, do we have everything for that? We're continuously updating the deadline. We're also watching for things that actually need closed out. Okay, and you would probably want to have some kind of buffer on this check when you're polling for what you can actually close out. You'd probably give the deadline a little bit of extra buffer. To do, yeah, you'd probably give it a little bit of extra buffer before you go ahead and try and close it out. So that way you don't have a bid come in literally the last millisecond. Okay, I'm going to look at the comments a little bit, and then I'm going to see what's next on my agenda for what I wanted to cover. You don't want to do real-time queries of OLAP for adjusting stuff, but I think I've drawn this out now. Okay. I think my computer really doesn't like OBS. That's maybe why it's slowing down so much. For total number of bids, data needs to be relayed often. So will we use OLTP? I don't think we actually need to show the total number of bids for an auction. If that is a requirement, that one would actually require real-time analytics if you did actually want to show the total number of bids, but I don't think that is actually a requirement most of the time. That would be an OLAP use case though. That would require real-time analytics like Flink or some kind of other count min sketch tool. Although I mean, so usually with that kind of thing, you're also talking about if it's an auction that's getting like 100 TPS, or if it's a specific individual auction that's getting like a lot of traffic. So it might be valid to use a count operation on PostgreSQL, but at some point, if you are handling auctions that are really, really big, for whatever reason, you might need to consider Flink. And I don't remember if DynamoDB does actually support count operations, because so this one's usually in the OLAP use case, like I said. So I'm not 100% sure if DynamoDB does support that, this keyword here. Didn't know about auth capture workflow. Yeah, you're welcome. It is rare. It is rare to see that. There's a lot of components that have some kind of payment component, and it's like, so you don't typically work with auth capture workflow like hands-on in your day-to-day job, and it's rare that you get hands-on experience with working with the auth capture workflow. But there's so many interview questions that actually use it, and so it's kind of a little important to understand it. And it's like you just wouldn't really there's not a lot of places that it's not really frequently taught. Can we use something like ask and bid trees that are used in high frequency trading? Oh, I know it. So I thought that was using something a little bit different. I thought it was using this like list. I thought it had this like the so it's one-sided. The bids are actually one-sided here, while in the stock market you have a bid-ask spread. I did actually cover this a little bit in a video that I did on the stock exchange. I did kind of cover that. In our case, we only have bids. But I'm gonna draw that out. I think this is a really fascinating question, though. So usually in the stock market, you'll have, so let's say it's Amazon, and let's say that Amazon is trading at something like 253.47 is what it says quoted on the thing. And then you're gonna have people with some limit orders on either side. And so then you're gonna have somebody that's bidding like 253.45. You're gonna have people at 253.40, let's say, and then you might have some kind of gap, and you'll have like 253.20. So that's on one side, and then on the other side, the other limit orders, you're gonna have 253.50. You'd have 55, and then let's say that there's I don't know 55, let's say 80 or something, and then you would have this list of 200. So you'd have like quantity is 200. You have another one with quantity equals 5, or usually it's in blocks actually. So usually I think Robinhood sells its order flow to something like Citadel or 2 Sigma, and so you're not really going to see this very often. You're usually going to see like 1,000. You might see 2,000 from some other person that's involved in market making, and then you would have another 1,000, and so you have this like list under each one. Let's say this one has a queue of 500. And then this one has, just have this. It goes the same way on the top half, like that. We'll have it look like that. And we'll maybe say, there we go. So it usually looks like this, where you have this mapping of different price thresholds to the pending limit orders that are either on the bid side or the ask side. And then you'd have market orders, so you'd have maybe a market buy come in. And these guys are all trying to, so these guys are trying to buy, these guys are trying to sell. And so then if you have a market order come in for buying, you'd run it against the sell orders, and that would hit this. So market orders would slap these ones, while a market sell would hit these ones. I'm trying to keep buy and sell straight, and which one's up and which one's down. I hope I did that right. But in this case, like I said, you would have, which ones are the bids, which ones are the asks. So these people are bidding, these are the bids, and then these ones are the asks. They want to sell it for high, and these ones want to buy it for low. So that's what you normally have, while in our case, we only have the bid side. And there's only one item. There's only one item we're selling, so you're not doing a quantity like this. We're working with a quantity of one of the item, and we're just going to accept the first timestamp that somebody, we just want to, Yeah, so if you want to put up the same price offer, too bad somebody else offered it first. That puts some time pressure on, of course, the people that are bidding. You have this exclusive item that you're offering, and so then that's what's a little bit different about auctions. But this is a very interesting thing. I think there's another part of it where it like maps the node off to the actual order object or something. There's a little bit more to it than this, but this is how the whole bid-ask spread works on the stock market while we're just working on the bids. Great question, though. That was very interesting. I totally didn't even consider that, but I think that did actually come up in my previous attempts to cover that content, is that some people try to compare it to the stock market. I mean, it's an interesting question, though. So that is what that is called. That's correct. It's a matching engine. Yeah. Next question, how to show things like X number of people watch. This will be my last question before I go ahead and try to move on a little bit further into the agenda, by the way. How to show things like X number of people watch this bid in the last 24 hours. How to figure out if a bid is hot. Put it in trending. How to show things like X number of people watch this bid in the last 24. Oh, that's like extra analytics on an auction. Those are some extra features. That would work off of what somebody else had said, where you would need that real-time analytics component. And I don't want to draw that out because I haven't even finished getting to the WebSocket thing, but if we have time at the end, I can go ahead and do that. So that was getting at what I had said over here. You would need to work off of that. Component from here. You'd pipe the output into the auction data store, and then you'd have a sort, and then you'd have a secondary index over it. And so it would have eventual consistency, of course, but that should be good enough. If you're using real-time analytics in the first place, it should definitely be good enough. Trying to make it strongly consistent would be one hell of a challenge. I can't imagine it would be worth it. I don't want to get too sidetracked with trying to figure out how that would work if you wanted to make it strongly consistent and 100% accurate exact counts. But this should get you close enough. Let's go ahead and move on to something else in my agenda, and then I'll get back to some other comments later on. I just realized you guys can't actually see the full text file right now. Jesus Christ, I hope that wasn't blocking your view of what I was typing. That would have been really annoying. Okay. What else was in my agenda? So we covered some questions. We did the continuous closing approach. WebSockets time. It is WebSockets time. I'm excited. I found out there was some kind of marker thing that I could have placed on the stream. That would have been great. Oh well. All right, so I'm going to go ahead and take, I want to take the simpler of these two things. and go ahead and turn that into the WebSockets approach, because this is also going to add a whole nest of, rat's nest of complexity. So we're going to take this one, which is the simpler looking one. I'm going to go ahead and shift this over to the left. So that way you can kind of follow along a little bit easily later on if you're reviewing it afterwards. I'm going to go ahead and copy this, and that's what I'm going to work off of for the WebSocket approach. We're going to put that over here. I'm going to say WebSocket approach. I'm obviously going to zoom in here in a minute. I just want to make sure that I'm still keeping everything eligible for anyone that wants to go through the diagrams offline. I know those are a little bit easier to skim. Here, I'll even give you guys the link for where we're at prior to me drawing out this next horrible thing. So this is a checkpoint is what I'm going to call it. There we go. That's my progress so far. And now we're going to draw this super nasty WebSocket thing. And I'm going to need to pull up my trusty. I am actually kind of looking at an answer key like while I'm going through this to like keep my head straight. Because I try and like, this is like my second pass through it. I want it to like actually kind of be solid this time because I don't want to do like a third pass. Yeah, okay, so what we're going to do is we have the bid data store. You're also going to want to have the connection set up. Since it's a WebSocket, you're also going to have, so you're going to have a first view of the bids, and then you're going to have subsequent views which are broadcast over the WebSocket. So you would have the initial view, and this whole thing is just going to be called the bid service. You're not going to call it the bid view service anymore. Although this one, you could actually have this one as, this one could actually be a RESTful service. This one doesn't necessarily need to use WebSockets. You could go ahead and make a REST call and not make use of your WebSockets bidirectional stuff, which is interesting. So let's go ahead and maybe have this thing set up a little. Yeah, so we're going to have this up here as a separate thing. Would maybe make a little more sense. This one's going to be for subsequent views. I'm going to delete that. This one is our schema. We can, you can just pull it off a different problem. You're going to have Redis pub sub, of course. We're just going to use a DB trigger for broadcasting it to everyone that is subscribed. Okay, and you would need to have the initial connection set up. The initial connection set up to the bid service. So this one is the combined bid service. Let's go ahead and stretch this over a little more. You know what, I'm just going to go ahead and copy that, paste that one. Okay, and then we're going to draw these dashed lines over here. Put some corners on it. Okay, and you're going to have a local store of the WebSocket connection. You're going to have these local references to it. You would need like you can maybe use like Redis sidecar deployment of where it maps a given user ID to a specific persistent WebSocket connection. Another good thing for this, I believe, is something called Envoy. I think that's for service discovery. There's some kind of service discovery thing you can add called Envoy, which is really, really good for this, I heard. It prevents this thundering herd problem from happening if you need to migrate a bunch of those WebSocket connections. Okay, so you have those WebSockets. You would do the first initial connection setup. You would also need to do you'd of course have an initial key range query of like, hey, what do the current bids even look like? You would need to do an initial read of like, what is the current winning bid since you're not already getting it pushed to you. And so you have your WebSocket, but you would also need to have the machine to user ID mapping. There would need to be some kind of key value lookup for user to what machine their WebSocket is on. So that way, and what auction they're on. So you have auction to the users watching. Hold on, I'm gonna need to do some writing here. So auction to viewers. And you're also going to need to have you do the fan out prior to the Redis pub sub thing. That's going to happen before it. Come on. You're going to have these task runners. So when you do a bid submission, it'll update over here, and then you're going to need to fan it out to everybody that's watching it. So you would have a DB trigger over to here. It's going to figure out who everybody watching it is, which is over there. And then it's going to go ahead and write a bunch of records to Redis pub sub. Like that. And then going to have something that is going to map it back to the right machine. Some, actually this thing pushes. This thing's going to push to, oh God. So you could have Kafka. You could have Kafka instead of Redis pub sub. I'm going to go ahead and start it with Kafka because that makes it a little bit easier for me to think about, and then we can maybe show how this would work with Redis pub sub. So this is going to be Kafka to start with. So then it's going to pull off some messages from here for some people that need updated on a new bid that has come in for a given auction. So it's already been fanned out. You need to have the... So when you establish the connection over here, this one is on establishing connection. And so you're also going to need to write that you're even watching it over to here. You're going to need to subscribe for updates to the auction. I didn't mark that this is a DB trigger. Okay, so we got the DB trigger over here. It comes in, you fan it out to all the watchers. Okay, and then you're going to need to map them to the appropriate machine, which is what the service discovery component would do. This could maybe also track what machine you're on. So then you would maybe get back auction to a map of the username and the machine ID that you're on. Okay, so you send over the machine ID and your username over to here. You get that back from the key value lookup. Or this is going to be a key range query. So this thing is going to be... Yeah, I mean, this thing would probably be PostgreSQL. There's probably a way that... I mean, there's also Redis, and you could have a set as the value. You could either have the set as the value in Redis, or you would just use PostgreSQL. Let me go ahead and write that. And so then you would still be able to do just a key value style lookup with Redis if you did that. So you fan it out, and then so you know the machine ID though. Then you would know the machine ID that you're going to send it back to. Okay, and then this is finally going to map from the username to an actual WebSocket connection. So you do need the username still. So this thing only really gets you the machine ID. You don't know which machine ID that username is located on, but then the username still needs mapped over to a connection. So you could also call that a username connection. So I've heard that Zookeeper, I think, can be used for service discovery. And Zookeeper is actually, I think I've heard that once at least. And Zookeeper is just a key value store. And so again, key value store like Redis or service discovery, hey, Zookeeper, I think can do that. And it's also just a KV store. And so that's kind of like what's going on there. And I'm just going to draw a little dashed line over to this. So that way we've properly annotated our thinking there. Yeah, otherwise you would have needed a user machine mapping. So that's like an alternative approach, and so I can just go ahead and draw that with like a dashed line is user and I'm not even clarifying how the keys would have gotten into there. You probably would have needed to do a write over here as well. The auction, so in WhatsApp, this is reflective of the group chat thing. This is like if you're in a group on WhatsApp, and so then it would fan it out to the group over here. And so that would have been a completely separate thing that doesn't just load up when you load the page. While this one is a user machine mapping, that's what we update, I believe, in the WhatsApp or Facebook Messenger problem. So then if you were going to use that, though, that meant that you would have had to do another write operation over here, like that. So that's an alternative approach. And this would have been I think we could even say this one could alternatively be some kind of service discovery component. Or, yeah, I have no idea how that works. I've never done that hands-on before. This is another thing where I would have, I'd really like to actually implement this thing with like Kubernetes in one of the future iterations on these problems. I'm going to look for if there's anything else in my agenda. I think that's everything, though. I want to check comments, of course, first again. But let me see if there's anything else in my agenda. So WebSockets fixed deadline variation versus the moving deadline variation. Yeah, and we've already kind of gone over that. I can talk about some different timing approaches as opposed to the polling thing for completeness on the coverage there. That could be a good idea. So I think we're going to do comments, and then I'm going to try and think a little harder about that little polling deadline cutoff closing thing. Okay, the last one I answered was how to show things like X number of people watch this bid. What's the ideal use case for CDC with DB triggers? So it's really kind of core to sagas. And again, CDC stands for Change Data Capture. Sagas, which are, that's a type of distributed transaction. They're really great because they allow you to do retries, and it's more of optimistic locking as opposed to so that's one of the trade-offs. One of the trade-offs is that it's eventually consistent. And then also it's optimistic locking though, and so it doesn't have the issues of two-phase commit. I don't know if it's actually called optimistic locking though. There's other stuff that you would maybe do in optimistic locking for invalidating work that was done on data that has gone that has expired or it's no longer accurate. So it might be considered optimistic locking. It avoids pessimistic locking, which is what you would do with two-phase commit. I think there's actually a term for this. It's coordination avoidance. It does coordination avoidance. That's maybe a much more accurate depiction of it. It has that's a huge advantage over two-phase commit. And then I guess you could even maybe talk about, so for coordination, what else is there for coordination? I mean, there's, I don't know if consensus is really considered. There's a way you could make two-phase commit more reliable and kind of kill the termination issue, which is by adding a transaction log run off of Raft in front of two-phase commit, and so then it doesn't have that nasty loss of that termination guarantee, the termination condition. So then that's like one thing that kind of you dodge is two-phase commit, and then or the alternative, which is also rather expensive, of some kind of consensus thing. Yeah. That avoids it definitely avoids contention. So as opposed to two-phase commit. What's the name for, how do I word this with the termination edge case? That's how I'll word it. I think you guys can figure out what I'm talking about there. It's described heavily in DDIA, how two-phase commit has this really bad edge case that can sometimes happen. Okay, I joined session late, didn't know if it's a real-time auction or not. Need to watch the whole video. Well, so that depends on what you mean by real-time auction. So I did talk about the concept of real-time constraints and whether you really need those here. So that is when you need linearizability, is if you truly need real-time constraints, you need to be able to say no, like right here on this thing, no, this thing. It's whether or not you actually need to be able to say no there. On the response back from the OLTP database and say like, no, we're not going to accept your bid because there's actually higher ones in there. Although, I mean, so if you're doing manually sharded PostgreSQL, it's pretty easy to do that and make it a bigger transaction operation and say that like, hey, your bid actually was not good enough. Yeah, okay, so I guess that would kind of define your database choice and what kind of consistency level you have there. Thanks for bringing that up, actually, is that I guess that does really help with expressing what you actually want to shoot for here with your consistency and database choice. Where did I kind of have some details on that? Let's go ahead and mark. Maybe I can make this like bright red or something. Let's actually go ahead and move that, and then we're going to go ahead and kind of draw that out. Not with a dash line. We're going to fix that in a minute. But that is the critical path right there where you need to be able to, that's the key piece right here that determines your choice. Is there a way to make it bold? No, there's not. Let's go ahead and make it red. I haven't done that in any of the other videos, but that's like a really interesting topic. As opposed to total. So total ordering is probably going to be required. Well, it's weird what the difference is between causal consistency and total ordering. You would definitely need total ordering if you didn't have the right partitioning key. But in this case, we have a partitioning key where all the bids for a specific auction are going to end up on the same machine. So it's a little bit more like causal consistency, I think, here. What type of queue are we using? That's right. I did draw that with Kafka. I did mean for that to be Kafka. I didn't write that down. But it is using Kafka right now, and I was interested in whether we could draw it with Redis pub sub instead. My screen's lagging a ton. Okay, So with Redis pub sub, so you'd push it out to, I mean, you could push it directly to the bid service, and then, so you do have the machine ID already kind of figured out over here, I guess. So I guess we can go ahead and explore that really quick. And we could call this like the Redis pub sub approach. Okay, and we're gonna zoom in. So we want to get rid of that. So I guess you could have a Redis pub sub queue dedicated to each machine. And so then you're mapping it to proper machines. So you'd be choosing like that as opposed to I misdrew that. That should be one way. We don't actually need that component. That was like an optional alternative approach. This is the WebSocket approach, right? Yeah. There we go. So for a given auction, you are returning a list of that. And so then you have a specific Redis pub sub for a specific machine. I guess I know how I can draw this out a little bit better. So you'd have one queue for one machine. And you'd have some for a different one. Sure, okay, I guess that kind of makes sense. So now we've drawn it with Kafka and Redis pub sub. Do you have a diagram link? If it's not showing up in the chat, if you're struggling to get a link to show up in the chat, you can go ahead and send it to me on Discord instead if you want. You can just paste it in there. Not seeing a link right now. Or you can go ahead and post it in the thread on Discord afterwards. Yeah, I think I still wanted to cover, what do I have up there? Other options for possibly handling the deadline or closing approach. Okay, so we got the polling thing. I think what I wanted to try and figure out if I could do is if I could do something with like distributed cron instead of the polling thing. So we've got polling, we've got what is it? Let's zoom out. I thought I had something that actually used DB triggers for. So over here we have the polling thing. It's continuously polling for things that are past the deadline, so you can finally close them out. Alternatively, so you could also have just scheduled that with a distributed cron job. So we could have tried to do that. So we're going to try the distributed cron variation with, I'm going to give a checkpoint for what we've got right now because it's already rather crazy looking. So we had the naive one from the very start. That was just the combined, well, I wouldn't even call this naive. It was just like if you did actually want to do something kind of like flash sale or Ticketmaster, we had that over there. Then I had the federated approach where there's the separated auction data store from the bid data store, which is kind of like what you normally see within Amazon with a pair of NoSQL databases where they just shove DynamoDB at literally everything. We covered the fixed deadline variation and the moving deadline variation for handling the closings. I did talk about how to maybe use an OLAP data store. And then we got these WebSocket approaches over here, and we're going to share the link for that. Okay, and now I want to try and do this one with the distributed cron approach. Okay, so when you schedule an auction, when you open it up, you would have a DB trigger over to your distributed cron thing. So it could be lambda, it could be and then instead of doing continuous polling, it would just activate at whatever time, like 5 minutes after the fixed deadline, and then it will just do one call, and it would be able to properly close it out. It wouldn't need to continuously poll. And I guess it wouldn't even need to do the Kafka stream. It would be able to just send it straight over to the orchestration component. And then I had a whole video going over 3 different approaches to distributed cron. I don't know if I really want to get into that. There's a couple ways to do it. I think one of them is even Golang threads. You can have some Golang threads just running on these machines that wait for a specified time, and then at that time it would do the call, and then it would go ahead and kick off the worker for doing the external payment service transfers. Let's go ahead and label these 1. And then we can have 2. Yeah, I really don't want to expand this thing out. That one is that one's literally its own problem entirely. Okay, can we do that over here? So we would need to like continuously update the thing that's running on those Golang threads, and so then it's then we would end up with we would either need to be able to cancel events that are scheduled, or we would need to have this thing do it run, and it would check whether or not the auction has actually closed. And so then sometimes when this runs, it would not actually be able to close out the auction. And so you would maybe have this several cron jobs running per auction. And then that seems a lot less, that could be even less efficient than the polling approach. It seems totally possible that it could be less efficient than the polling approach. I don't think I even want to draw it out for the continuous closing approach, or the moving deadline variation. I don't want to draw out the distributed cron one for the moving deadline variation. It just doesn't really make as much sense there. I'd really like this to be the last time that I cover this problem. That's why I'm taking so long on it. I'm really not thinking of a whole lot of other things that we can do with this, though. And I don't see any questions in the chat. I can't believe some of you guys are still watching that. I really appreciate that. I think we're good, though. We can go ahead and wrap it up. I'll go ahead and stick this last link into the description for the video. So I'm going to edit the video. Come on. I guess I can even drag this onto the other screen. This is just what I'm trying to do right now. I got this rainbow wheel of death. No, where'd it go? Oh. Right, that is what we wanted. Right, come on. There we go. Got it. All right. Thanks for joining, guys. I appreciate that you have joined me for this session. I think we've really done a great job with this problem. It's way more thorough than we did on the original coverage for online auction. It's way better. I'm really happy with this content. thanks a ton for joining me, and I will see you next week. If you have any questions, feel free to drop them in the Discord. Otherwise, thanks again. See you guys. So Rob, you can post it in the thread that I open up for. You can actually post it just in the online auction, the original online auction thread. I'm just going to reuse the original online auction thread from Discord for this, for reposting the Excalidraw from this current run of it. So feel free to drop it over there. Yeah, all right, I'll actually wrap it up this time. Thanks again. See you guys.